Hello everyone, this is Dmitry from Galileosky, and in this video we will keep talking about tracking devices in industrial automation. This time let's have a look how the tracker can be added to the SCADA system as an actuator. In this case, the tracker acts as a Modbus-TCP server and responds to requests from clients. Clients can be OPC server, SCADA system, PLC, and so on. The tracker also works as Modbus-TCP to Modbus RTU gateway and allows SCADA system to work with Modbus devices connected to the tracker with RS-485 or RS-232 interfaces. The Modbus-TCP server features are available on Galileosky 7X Wi-Fi hub trackers, starting with the firmware 44.4, and Galileosky 10 hub devices, starting with the firmware 1.1. The configurator should be version 5.2.01 and higher. First, we need to download the EasyLogic Modbus-TCP server algorithm to the tracker. If the internet connection is available, you can download the algorithm from the server. You can see the command for loading the algorithm on the screen now. You can also download the binary file from our algorithm store. Just type the Modbus server in the search bar and download the file. Please remember that binary file should be uploaded to trackers from EasyLogic tab. Upload binary button. Next, configure the serial interface that you are using to connect your sensor to the tracker. If it is the RS-232 port, select nothing in the peripheral type field. If you plan to use RS-485 interface, select one of the following modes: Galileosky camera and FLS, EasyLogic RS-485 handler only, EasyLogic camera handler and FLS, Modbus, or FLS and Modbus. Apply the changes and reset the tracker. Now, new tab called Modbus-TCP server is available in configurator settings. On this page you can specify the port that clients will use to access the Modbus-TCP server, which is now our tracker. The default port is 502, so let's keep it this way. In client settings we will need to use this port. Below we can enable or disable the Modbus RTU gateway feature. Enable it if you want to give clients access to devices connected to the tracker serial ports. Next, we need to select the interface and make settings for it. Those settings should match the settings of devices that are connected to the tracker. Apply the settings. When receiving a request from the client by Modbus-TCP to the respective address, the tracker will automatically send this request by Modbus RTU protocol and return the response it received. To get the parameters of the tracker itself, there should be a request from the client to the address or unit ID 255. This is the address that Modbus-TCP server has. Additional devices working with the Modbus RTU protocol can have addresses or unit IDs from 1 to 247. Modbus-TCP server can handle requests from up to 3 clients at a time. If there is a request from the 4th client, the connection with the first one will be broken. To obtain the data from the tracker itself or to change the state of its outputs, clients should send requests to the respective registers. The list of registers is available in our knowledge base, in the article about using the Modbus-TCP server algorithm. This article has detailed instructions how to set up the tracker to work as a Modbus-TCP server, and at the very beginning of the article there is a link to the list of registers. To pull devices connected to the tracker, the client should send requests to the devices' addresses, and the register table should be taken directly from the manual for that device. The tracker and the computer running the OPC server must be in the same network, and this network might be a virtual. OPC server addresses the tracker by IP, so it is better to configure the HTTP server of the network so that the same IP address is always given to the tracker by its MAC address. You can always find out the tracker's Wi-Fi MAC address in configurator on the device tab. Now let's see how the OPC server is configured. There are 2 objects connected to the server: TCP and gateway. TCP is the Galileosky 7X Wi-Fi hub tracker. Its properties show the IP address and the port of our tracker inside our network. Let's pull the tracker itself according to the list of registers I mentioned earlier. Some registers are here as an example. For instance, this is how the settings of the register that stores the values from the input 0 of the tracker look like. The gateway is the Modbus-TCP to Modbus RTU gateway, which is organized by the EasyLogic algorithm uploaded to our tracking device. So, its settings look similar. It has the same IP address and the port. As a sensor, we have connected a Modbus light sensor MSU21. The device settings are taken from its manual. Here, for example, it's the address of our sensor. To get the light level value, we pull the corresponding register, which is called light. Again, all the settings are made according to the manual on our light sensor. Now we are going to take a look at how this system works. Let's start the simple SCADA, where we already have the prepared demo project. On the screen you can see the readings from the light sensor and the readings from the Galileosky tracker inputs. There is also an indicator showing the status of output 0. I've connected an LED to this output. Now I use my flashlight on the light sensor and the readings in the SCADA system change. It turns off output 0 automatically and the LED is off. I remove the flashlight and values change again. The SCADA system logic sends the command to enable output 0 and the LED lights up. Now I turn the voltage off at the input of the tracker itself. The readings in the SCADA system change again. So now you know how Galileo trackers can be used in industrial automation solutions. I hope those videos will help you to find use for tracking devices in new areas and applications. That's all for today. Thank you for your attention. That was Dmitry from Galileosky. See you later.